In this tutorial, we're going to have a look at some of the common operations that you perform on an array, and we're also going to integrate functions into it. So to begin with, what I'll do is to create an array, and to do that I'll follow the template that we had talked about in the lecture. I'll say int bracket bracket my array, gets a new int, and specify the size, and we'll purposely keep this array small so that we can print it out and visualize and see what's going on. But what I've done here in line 4 is to create an array of 15 ints, and it's called my array. And as a reminder, remember the indices are between 0 and 14. So the next thing that I like to do is to print out an array. So to do this, what I'll do is create a function, public static void, and I'll call it print array, and just kind of stub it out here. Now remember, we're going to pass the array my array from main as a parameter up here to print array. So the first question is, how do we do that? Well, I'll come up here and type in the data type, and we'll just call it R. So what's actually going on here is that we're taking this reference here, my array, and we're copying it up here into R, but the end effect is that we actually are going to change my array down here in main at the very end of it when that time comes. All right, so remember there's this relationship between loops and arrays. So let's stub in a loop, and I'll say for int I starts out at 0, so long as I is less than, and then the question becomes less than what? Well, there's a length attribute here, so I can say r.length and then I++. In other words, we're going to hit every single element that's on the inside of this array called ARR, or just R. All right, now what are we going to do? Well, let's try to make it so that it's kind of pretty. I can say system.out.print, and we'll print out this little pipe bar here, and that's above your enter key if you're looking for it, followed by whatever is in the particular slot that we're talking about. So to review this, you probably already saw this in the lecture, but look at what we're doing. We have a counter called I that's going from 0 up to, in this case it's going to be 14, and we're going to print out every individual element that's there in addition to this little pipe symbol so that it kind of spaces things out correctly. The magic is actually right here, because remember we're talking about the array, the entire array, and then we specify the individual element that we want to print out. And that's going to go from 0 up to 14. Okay, the last thing that's usually a good idea is to have a system.out.println here, just so that it drops down to the next line when we're done printing. Okay, so let's see what happens here if I call print array, and I pass it my array. And now when I run it, and I should save it here, you can see that we have all of these default values that we get with arrays, and they're all going to be zeros for numbers like we had said previously. All right, so the next thing that I like to do is to have some kind of initialization function. In this case, let's say that we're going to put random numbers between 0 and 9 inside of the array. Now, I don't know if you've played around with the random function, but here is your chance. So it doesn't really matter if I put this function above or below print array. It doesn't really matter in Java, but it does in some other languages. So let's just go ahead and stub it out here. I can say public static void init array. In other words, initialize the array. And we'll do the same thing that we did before. We'll create this parameter called R. And again, just like we had previously with printing out the array, we have to have some kind of loop that's going to work on that. So I'll do the same thing. I'll say for int I starts out at 0, so long as I is less than r.length, I++. And then what are we going to do on the inside? Well, here's something that's a pretty common kind of thing. You would say r of I gets some kind of value, let's say 10. Now, if I were to leave it this way and call this function, this would go through each slot manually and put the value 10 inside each slot, kind of like what we saw in the lecture. In this case, I don't really want to do that. I'm going to have to do a couple of different things. So I'm going to build up this expression and kind of explain what's going on. Now, the first thing that I'll say is math.random. And as a review, remember this math.random is a static method. How do I know it's static? Because I can just say the class name dot and then the function name. In other words, I didn't have to create an instance of a math to be able to call this random method. So notice that we've got a little squiggly right here, and the reason is because math.random returns us a double, and we can't put a double into something that's expecting an integer. So how are we going to fix this? Well, let's first of all say that we're going to typecast here. So whatever math.random returns is going to ultimately be typecast back into an int. Now, the problem with this is that math.random actually returns us a double that's between 0 and 1. So if I want to scale this thing up so that it's between 0 and 9, what am I going to do? Well, oddly enough, I multiply it by the value 10. I'm going to put all of this in a pair of parentheses. And the reason is because when I convert into an int, it's actually just going to chop off the everything past the decimal point. So 9.999 would be the largest value that we would get, which would then round down to 9. So walking through this again, math.random returns us 0 to 1. We multiply that by 10, and that's going to scale it up. And then we're going to typecast that into an integer, and we're going to put that into an individual slot. So that's a lot of code, or it's actually not a lot of code, it's just kind of complex code. But let's go ahead and call the function. So I could say init array, passing it my array. And then what I'll do is I'll print it out again right here. Print array, my array, and we'll see if it actually worked. Okay, when I run it and save it, you can see that we now get a whole bunch of random numbers between 1 and 9 inside each slot. In fact, I could run it again. You can see more random numbers. Run it one more time, and we really are getting random numbers, which is good. Okay, so that's another kind of common operation that you're going to see. We have print array so we can visualize it. We have init array so that we give them some kind of starting values, and they can be just about anything. Another thing that's fairly common is to do basic operations on the array. You might want to find the minimum or the maximum or the average or the sum or any of that kind of stuff, and they all start to kind of look alike over time. So let's go ahead and find the minimum of the array, and I'll create another method here, public static void, and let's just call it min of array, though you can call it anything you want. And again, we'll pass the array and we'll call it r. And then on the inside, as you might expect, then we're going to have some kind of loop, and we know that we have to do that because we have to hit each element. So I'll say for int I get 0 so long as I is less than r.length, then I++. And then what do we do on the inside? Well, the secret to finding the min or the max is to keep around an extra variable that's going to represent the smallest thing that we've seen so far. So what I can do is come up here and I'll say int smallest so far. And then we have to initialize that to something. So typically what you do is you assign it something inside the array. And it could be slot 0 or it could be anything inside the array. It doesn't really matter. But the point is that we now have the smallest thing that we've seen so far. Now on the inside of this loop, what we're going to do is compare the smallest thing that we've seen so far with the current slot that we're looking at. So what would that look like? We could say if the smallest thing we've seen so far, is greater than the array slot that we're looking at, then what do we know? Well, we know that the smallest thing so far is greater than the slot, so we need to update the smallest thing so far with whatever slot we're looking at. So I could say smallest so far gets r of I. Okay? At this point, we found the smallest thing so far. We've looped through every element that's there, but what do we do with smallest thing so far that we found? Well, how do I get it back down here so that it can be seen by main? Well, this is the problem right here. I've got a void return type. So what I'll do is I'll change that from void to int, and then down here as the last statement, I can say return smallest so far. And when I do this, whenever I call min of array, I should expect to get back an integer that represents the smallest thing that we've seen in the array. So let's see if it actually works. Here I could say let's say system.out.println min of array, and we'll pass that my array. So don't let this be intimidating at all. Notice that we have a system.out.println, so whatever min of array returns us, it's just going to be printed to the screen. So I'm calling a function inside calling this function right here. Okay, so let's see if it actually works. I can run it and save it. And then you can see that it initialized it all to zeros by default. We initialized it with a whole bunch of random data, and then it found the smallest thing so far, which is a 0, which you can see is right here, and there's actually another one right here. Let's test it again. Run it again, and you can see that there's another 0. Let's see if we can find one that doesn't have a 0. May take us a couple of times. And there we go. Okay, so you can see the smallest element that is inside of this array is the number 1, and I think we have another one right here. All right, good. So it looks like that is working. All right, so the last thing that we're going to do is to look at how to sort an array. And this is something that computer scientists study quite often. The sort that we're going to implement here really isn't a very good sort. It's not used that often, but it is good for educational reasons. So let's go ahead and stub in a function that can do that for us. I could say public static void sort array. And we'll do the same thing that we did before, having r as a parameter. Now the way that this thing is going to work is that we're going to start on the leftmost array here. You can see that's a 6. And we're going to scan across looking for the smallest element of the entire array. Now when we reach the end of this during that scan, we know that we found the smallest thing so far, so I can swap it with the 6. And therefore the smallest element is now in the correct spot here in the leftmost slot. Then we move over here to the next slot and we scan across looking for the next smallest thing in the array. And then we do another swap once we reach the end of that. So at this point I now know that I have 2 elements that are in the correct spot. Now to be able to do this, I have to have 2 different loops, and I have to put one loop on the inside of another loop. The outer loop is going to be the one that's responsible for going across each slot all the way from left to right. The inner loop is going to be the one that is responsible for scanning, looking for the minimum from whatever slot we're looking for over to the right-hand side. So what is that going to look like in code? Well, we're going to have a for loop that's going to be for int I, starts out at 0, so long as I is less than r.length, I++. And then on the inside of that, I'll create a little bit of space. I can say for int j is going to start out at whatever slot we're looking at. And this inner loop, again, is what's going to scan from the current slot over to the end of the array, looking for the smallest. So I'll say that int j starts out at I, so long as j is less than r.length, j++. Okay, so you can see that we've put a loop on the inside of another loop, and we're going to get some good behavior from this. All right, now we're not done. We need to find the smallest thing that we've seen so far. So let's create a variable for that. Int min so far, gets r of I. So we're going to say that the minimum thing that we've seen so far is the current slot that we're looking at. And then we also have to hold on to the index. So I'll say index of min gets I. Okay, so remember, the inner loop is the one that's responsible for scanning across. So what we'll do is we'll look for the smallest thing so far. And if we do find something that's smaller, then we need to update min so far. So we'll do that exact thing. I'll say if r of j is less than min so far, then what are we going to do? Well, we found something that's smaller, so I need to say min so far gets updated with r of j. And then I'll say also the index of that minimum is going to get j. Okay? So at this point we're in pretty good shape. We've scanned across the entire array for the slot that we're looking for. And so now we know that we can do this swap. So to swap a couple of numbers is relatively straightforward. We can say int temp gets r of I. And then r of I gets whatever we've put in our min so far variable. And then the last thing is to update whatever it is that we swapped from. So index of min gets temp. Okay, so how do we know if this thing's actually working? Well, I can come back down here, and here let's just comment out this system.out.println, and I could call sort array, passing it my array, and then finally right after that I can call print array. Okay, so we can run it and save our work, and then you can see initially here's all of the zeros that we get by default. We've initialized each slot to some random number, and then you can see right here the next line down we've actually sorted all of that information. We have a pair of zeros that are there, followed by a 3, a couple of 4s, and so on and so forth. So what I would recommend that you do is to look at this sort array, and I know it looks like a lot of code, especially if you're first learning how to program, but I would take out a piece of paper and I would put down some random numbers that are in an array of, let's say, 5 or something like that. I would walk through all of the code that you see here between lines 27 and 42 and manually go through the process of seeing how the data is actually moved around, draw out little boxes for all of your variables and everything else, and then understand how that algorithm is working. So that's it for now. Hopefully you understand a little bit more about the practical side of working with arrays.